Today, Algebra 2 Honors class covers section 5.2 and section 5.3. It's about multiplying and dividing rational expressions. Okay, so let's have a quick recall. What we did for multiplying regular fractions here. So let's make a real quick example. So if you are supposed to multiply 2 over 5 by, let's say, 10 over 15, right? Then the way that you multiply is the numerator multiplies the other numerator. So it's going to be 2 times 10 and 5 times 15, right? Then in this case, when you multiply them crossly, and you can just go ahead and multiply and then have the value from each side, then you can simplify later. But also what we can do is we can verify some factors and recognize 5 can simplify 10 from the numerator side. So I can have this simplification first, right? Then the denominator is 15. Then the numerator is 2 times 2 is 4. Okay, so this is what we did, right? Okay, then let's go ahead and try out division. So this is how we multiply the fractions here. And what if we had 2 over 5 divided by another fraction like this. Here, what we algebraically used to do is we keep the first fraction as is, but we get to change the division into multiplication. Then now we get the reciprocal of the divisor. So now we have 15 on the numerator and 10 on the denominator. So reciprocal of the divisor. Then we went ahead, multiply 2 times 15 and then 5 times 10 here. Then in this case, the procedure is exactly same what we did for the multiplication. Only added extra step for the division with fractions is you take care of the division into multiplication, and then you took care of the divisor as the reciprocal, right? So then let's see what we can do here. Then you can go ahead and multiply numerators and denominators separately, and then you can simplify. But what we did differently is I recognize the 5 and 15, so it's gonna be like 3 here, right? Then here, I even simplify further with a 2 and 10, so it's here, right? Then the result is gonna be 5 on the denominator and 3 on the numerator. So this is a typical steps for us to do multiplication and division with regular fractions. Okay, I assume everybody remembers how to do it. Just in case. Any question? Are we all good? Should be good, okay. Then let's have two typical multiplying and dividing rational expressions here. So then number one, now we have 3x squared over x squared minus 2x minus 8 multiplied by 2x squared minus 6x minus 20 and x squared minus 3x minus 10. Okay, now I have two separate rational expressions. The first one is 3x squared over x squared minus 2x minus 8 is multiplied by numerator 2x squared minus 6x minus 20 over denominator x squared minus 3x minus 10. Then, from the previous lecture, whenever you deal with rational expressions, that there's one condition that you responsibly should claim is the excluded value. This applies for the multiplication and division as well, right? Okay, then the excluded value should be from the denominators, right? Then also, one more important reminder for rational expressions is each rational expressions separately from numerator side and denominator side, and you have to examine if that's further factorable, and if so, then you have to do it. Then I can see we can factor further or separately, right? So then let's go over factoring each side first. Then 3x squared, it's not further factorable, so I will write it down. Then the denominator of the first rational expression, x squared minus 2x minus 8, and then I can factor that. So now I factor this way. So the factors of x squared is x and x. Factors of 8 could be 1 and 8, 2 and 4. But in this case, we pick 2 and 4 as the right factor. So I can say 4 and 2. Then in this case, in order to match the midterm coefficient -2, 4 gets negative and 2 gets a positive. So now I'm done factoring the denominator of the first rational expression. Then it was supposed to multiply here. Then the numerator of the second rational expression has a 2x squared minus 6x minus 20. And I noticed all the coefficients are the family of the multiples of 2. So why don't we factor 2 out? That's common factor. Then it's going to be x squared minus 3x minus 10 here. And then denominator was, x squared minus 3x minus 10. So I already see this happens to be the same, but I will just keep factoring further if I see more smaller linear factors to cancel, right? So then let's factor it. So it's going to be x and x. Then two factors multiplied to be -10, added to be -3 is -5 plus 2 here. Then let's take one more step because this is our first example. So it's gonna be this 3x squared over x minus 4, x plus 2. Then now it's a 2. Then let's factor x squared minus 3x minus 10 on the numerator side. So it's going to be x minus 5 and x plus 2. And it's x minus 5 and x plus 2. Now I have to recognize them as common factor from top, from bottom, right? And then this is a multiplication. So we can just consider, technically, this is gonna be all together like this. 3 times x squared times 2 times x minus 5 and then x plus 2. Then it's gonna be x minus 4 and x plus 2 and x minus 5 and x plus 2. Right here. Then now the way that we recognize it is here. I see x plus 2 there, right? Here, now I use x minus 5 cancels the x minus 5 on the bottom first, right? Then notice there's x minus 2 here, but x minus 2 on the bottom appears twice. But I cannot cancel both from the bottom by only once from the top. So in this case, the way that we can cancel is this. If I cancel x plus 2 with the first appeared x plus 2, and I have to keep the second x plus 2 from the bottom as it is, right? Okay, then is there any other factors for us to recognize and cancel? Not really. Then I can go ahead, multiply everything so that I can come up with the simplest form here. So 3 times 2 will make 6, and then x squared was left. And then now what I have here is x minus 4, x plus 2, so it's gonna make x minus 4 and x plus 2. Now we're done simplifying it. We're done multiplying and simplifying it, but we never actually responsibly claim the excluded value, right? Then, question for yourself. What was the answer for the question that do we just consider the excluded value from the simplified form, or we have to take care of the original one? So which one was it? We needed to go back.
Simplified form?
Yeah, so, but after we simplify, we get this one. So in this case, the excluded value is only 4 and -2. But we simplified as we along the way, but originally what we were given was this. So it might not be easy for us to get the values from the non-factorable form, but I will take a look at entirely factored step here. Then I will recognize my excluded value here. right? So even if we happen to cancel, we happen to cancel x minus 5 and then x minus 5. But it was there as a given part, right? So then, oh, you know what? Actually, it might be more convenient that we look at this, because this is the entirely factored form. Then for the excluded value, I don't have to worry about the top, right? I only look at the bottom. So now I have to announce the excluded value. X cannot be what? X cannot be 4 because it's gonna make this factor 0, and then it's gonna make all denominator 0. Then X cannot be what now? -2. Because if X is -2 here, and then it might have made the denominator 0. Then also, I have to look at this factor. Even though we cancel them, we still have to consider what was originally given entirely. Then 5. So you make sure you make this set of excluded value for this one. Okay, any questions so far? So we have to provide the simplest form after you're done multiplying and simplifying. And also you are responsible for announcing the excluded value. And when you exclude the values, not only the survived factors from the denominator, even some factors that happens to get canceled earlier, you still have to say it. Okay? Then, same manner, we will do one more example for the division. So division is nothing but that you take care of the division, change it to multiplication, and the rest of the steps are the same, okay? Then now I have x plus 7 parenthesis square over x squared. And then this is divided by x squared plus 9x plus 14. And x squared plus x minus 2. Then the first step before we even examine each part, factorable or not, and I know for sure I have to do the changing this into multiplication. Then I have to get the reciprocal of this. So it's gonna be this, x squared plus x minus 2, and then x squared plus 9x plus 14. So now it gets the reciprocal here. Then also another thing that you need to remember is here, x plus 7 parenthesis square is x plus 7 times x plus 7. So I can write that. Then the denominator is x squared. Then the next step, then I have x plus 7, and then x squared. Then now I can further factor this. The numerator of the divisor is x and x, and 2 and 1. Then since I have to make a positive 1 in the middle, so it's plus 2 and minus 1. Then the denominator is 2 parentheses goes x and x. And 2 and 7 will multiply to be 14, added to be 9. So it's 2 and 7, but both positive, okay. So now I only get to multiply them all over. So if I just add one more step, it's not really mandatory. So it's gonna be like this, x plus 7 times x plus 7 times x plus 2 and x minus 1. Then denominator is x squared and x plus 2 and x plus 7. Then now I can recognize the same factors. So the first x plus 7 will cancel this x plus 7. Then is there more same factor? Yeah, I see that. And then there's x plus 2 will cancel this. Besides that, I don't recognize any other. So now I can go ahead and take care of those survived factors. And then denominator is this. Okay, then now we should not have forgotten announcing the excluded value. But here, one more question arises for division, because look, now I get to see originally x squared plus x minus 2 was the denominator besides the x squared here, right? But then because of the characteristics of the division with fractions, we happen to reciprocal the second one. So now x squared plus x minus 2 is not denominator anymore. X squared plus 9x plus 14 becomes the denominator. So in this case, what do we do? Actually, the divisor, whether it's numerator or denominator, they happen to involved with excluded value, both. So in this case, excluded value covers both sides, okay? So now, remember this. Once you are originally divide, then the excluded value has to cover every factor becomes the denominators, right? So then from x squared, x cannot be 0, right? Then from the denominators with x squared plus 9x plus 14, x cannot be negative 2, x cannot be negative 7, right? But we have to also take care of the original expression that x squared plus x minus 2 was the denominator before we got it flipped over, then x cannot be negative 2, but that was already covered by this. So one more excluded value, x cannot be positive 1 either. So this is what we have to exclaim here. So this is here.